Hello everyone, today we are on lesson 2, which is situation and solution equations for addition and subtraction. By the end of today's lesson, you will be able to write addition and subtraction equations to solve problems. First, let's get started by talking about these two symbols. These two symbols equal and not equal to. So an equation is made up of two equal quantities or expressions. An equal sign is used to show that two sides of the equations are equal. We have talked about this before. We know the difference between an equation and an expression is that an equation has an equal sign, and we know that equal sign is there to show us that both sides of the equation are equal. In these examples below, you will see that they all have equal signs, so they are considered to be equations. Each side of the problem is equal to the other side, so both sides of the equation are equal. There is also a not equal to sign, and that basically looks like an equal sign with a slash through it to demonstrate that it is not equal. When you see this symbol, you know that the quantities on each side are not equal to each other. And below, I've put a couple examples of what that looks like. Each side is not equal to the other side. An equation can have one or more numbers or letters on each side of the equal sign. A sum or difference can be written on either side of the equal sign. And we've talked about what sum means, and we've talked about what difference means. In case you forgot, sum is when you add two numbers together and get an answer. So it's an answer to an addition problem. The difference is when you subtract two numbers and you get an answer, which would be the answer to a subtraction problem. We have also discussed inverse operations, so this is kind of a review on that. Inverse operations are operations that undo each other. We are going to be specifically talking about the inverse operations of addition and subtraction. Let's take a look at this break apart model to talk a little bit more about situation and solution equations. At the top of the break apart model, you will see the total or the sum, and at the bottom of the branches, you'll see each addend. In this case, our total is 81, and we have one addend of 72 and another addend of 9. There are several equations that we can come up to represent this break apart model, but I've decided to show you two. The first one I have come up with is 72 plus 9 equals 81. That shows both addends equaling or giving us the total of 81. We can also come up with a second equation, which would be 81, which is our total, minus 9, which is one of our addends, and that gives us 72, which is the other addend. Well, let's take a look at this equation. What if we had this problem, 81 equals 9 plus s? How could we solve for s? This type of equation that shows the structure of the information in the equation is called a situation equation. We haven't solved for the variable yet, but we at least have the structure and we know what information we need to solve for s. Once we actually solve for s, we come up with another equation, which is 81 minus 9. We know that if we complete this operation, we will get our answer for our variable, which is s. When we have an equation like this, we refer to it as a solution equation. In this case, our answer once we subtract 81 minus 9 is 7. So s equals 7. There's a difference between when we have the information and the structure of our equation, that is called the situation equation, and when we know what operation we're going to use to solve for that equation, we call that a solution equation. We are going to practice with a couple of problems for situation and solution equations, specifically for addition and subtraction. Let's look at this first problem that we have. In order to solve this problem, I wanted to do the cube strategy first. The letter C in cubes tells us to circle the numbers. So I went ahead and I circled 2,152, and also 628. The U in cubes tells us to underline the question. Our question here is how many coins are not pennies? And finally, in our cube strategy, we're going to do the letter B, which tells us to box important words. An important word that I found here was the word not. With that information, I have a feeling that if I subtract, I will get the answer. That keyword not gives me a hint that I'm looking for a difference. The difference that I'm going to find here is 2,152 minus 628. I think that this is going to give me the amount of coins that are not pennies, and that's why I made it equal the variable C. This is my solution equation because I know which numbers I need to subtract in order to get my variable. Once I subtract these two numbers, I was given the difference 1,524. Therefore, my answer to my problem is 1,524. Is C equals 1,524, which means that there was 1,524 coins that were not pennies in the collection. Let's take a look at our last practice problem. It says Susanna took $3,050 out of her bank account. Now she has $11,605 left in the account. How much money was in Susanna's account to start? Just as we did in the last problem, I want to go over the steps in cubes. C tells us to circle the numbers, so I circled 3,050. I also circled 11,605. The U tells me to underline the question, so I went ahead and did that. And then finally, I boxed a keyword that I felt was important, and that was to start. So it was a phrase that I boxed. That word is important to me because I know that means there's going to be a number that I'm looking for that Susanna had in her bank account in the beginning before she started taking out money. And that's what I'm looking for in this problem. So let's look at a couple equations that we are going to use to solve for the answer. The first one that I came up with is S, which I used to represent the start, the money that she had in the beginning. So S minus 3,050 equals 11,605 because that's how much money that she has left in the account at the end of her transactions. This type of problem that shows the structure of the information in the problem is called a situation equation, which we discussed in the prior slide. The next equation that I came up with was, how do we solve for S? Well, S equals 11,605 plus 3,050. I'm going to use the inverse operation or the opposite of subtraction in order to get my answer. This kind of problem or the operation that leads you to the answer is called a solution equation. In order to get S, I'm going to have to add 11,605 and 3,050. When I go ahead and do that, I get the answer 14,655. So S equals $14,655. This is how much Susanna had to start with in her bank account. It does take a little bit of practice to do word problems. If you start off by doing cubes, that strategy of circling your numbers, underlining the problem or the question, and then boxing important words, it'll definitely help you to be able to start on the right track. You can go ahead and do your homework on Think Central, and then I will see you on Tuesday for our Google Meet. So long.